This equation using Cramer's rule. Cramer's rule is probably the easiest way of solving solving systems for their unknown, because what you do is utilize the principles of determinants. So in order to solve for the unknown using Cramer's rule, what we're going to do is, this is 8, 3 minus 12, 2. What we shall do is we're going to put it in matrix form. This is 8, 3 minus 12 minus 5 minus 2, 8. This is 10, 4, and minus 15. This is just the matrix of all the coefficients, all right? And it's being multiplied by x, y, z, and that is going to be equal to 2, 3, 1. Now, what's the beauty about Cramer's rule? With Cramer's rule, what we're going to do is call this coefficient matrix right here, which is the coefficients of the x, y, and the z, we're going to call it A. All right, we're going to call that A. We're going to call this matrix A, where A is equal to 8, 3, minus 12. This is now minus 5, minus 2, 8. Then we have 10, 4, minus 15. This is our matrix A. Nice. Now we're going to find the determinant of the matrix A. And the determinant of the matrix A is going to be equal to, finding the determinant of this matrix, it's 8 times, in bracket, cross out this row, cross out this column. This is now minus 2, 8, 4, minus 15. And then now we have 8, then minus 3. It's going to be minus 3 times, cross out the row and the column with minus 3. We're going to have minus 5, 8, 10, and minus 15. And then this is going to be plus minus 12. So it's really minus 12 times, in bracket. This is going to be now, cross out this row and cross out this column. This is now minus 5, minus 2. This is 10, and this is 4. Yeah, man, beautiful, soft. And we need to find the determinant of A. So to find the determinant of A, this is now going to be equal to 8 times, let's work it out. It's going to be 8 times. We're going to simplify this now. So it's going to be minus 2 times minus 15. We know that is 30. That's 30 minus 8 times 4 is 32. Yeah, man, so we close that bracket. Then it's going to be minus 3 times, in bracket, minus 5 times minus 15 is 75. 75 minus 8 times 10 is minus 80. We close that bracket. Then we're going to have minus 12 times, in bracket, minus 5 times 4 is minus 20. Then we have minus 2 times 10 is minus 20. So this becomes plus 20. That part works out to be 0. So the final answer for the determinant of A is 8 times 30 minus 32 minus 3 times 75 minus 80. This works out to be negative 1. That's the determinant of A, negative 1. Nice. Now, what's the beauty of this? The beauty of this is the determinant of A is negative 1. Now then, we're going to write down a new matrix. Let's do it in another color. A new matrix A1. A1, what we're going to do is, wherever you see that we have, wherever we have all the x coefficients, we're going to replace it with the result coefficient. So we're going to replace 8, minus 5, and 10 in the matrix A with 2, 3, 1. So we're going to put 2, 3, and 1 right here. And then write back the other coefficients. So the other coefficients are, this is 3, minus 2, and 4. And this is now minus 12. This is minus 12, 8, and minus 15. Yeah, man. Yep, easy, soft. So now we can work out the determinant of A1. So to find the determinant of A1, this is going to be equal to, it's going to be 2 times the determinant of, cross out the row and the column with 2, and we're left back with minus 2, 8, this look like 4, and negative 15. Yes, yes. Then it's going to be plus, well, actually minus 3 times. Minus 3 times, cross out this round, this column, we have 3, 8, 1, minus 15. 3, 8, 1, minus 15. And then finally, we're going to have minus 12 times the determinant of, cross out this row, cross out this column, it's 3 minus 2, 1, 4. This is going to be 3 minus 2, 1, and 4. Nice and easy and soft. So what we're going to get now is that the determinant of A1 is going to be equal to, this is what we need to know to find the determinant of A1. The determinant of A1 is going to be 2 times, let's simplify this now, minus 2 times minus 15 is 30. That's 30 minus 32 again. This is now minus 3 times. This is now minus 3 times. 3 times minus 15 is minus 45. Minus 8 times 1 is 8. Beautiful. Minus 12 times 3 times 4 is 12. Minus 2 is plus 2. All of this will work out to be, put that in a calculator. 2 times 30 minus 32 minus 3 times minus 45 minus 8 minus 12 times 12 plus 2. All of this works out to be negative 13. All of this works out to be negative 13. So now, look at this now. This is how you find x. So what we're saying now is x is equal to the determinant of A1. X is the determinant of A1 over the determinant of A. X is the determinant of A1 over the determinant of A. So x is equal to negative 13 over negative 1, which works out to be 13. So we get one part of the solution already. Can put a box around it, x equal 13. This is Cramer's rule. Yeah, man, beautiful. X equal 13. Nice, x equal 13. So of course, we're gonna just do the same now for the coefficients of y. So let's do it in a different color. Let's use a different color. Let's use green. So now what we're gonna do now is we're gonna change the coefficients of y's in A2. So we're gonna write back 8 minus 5, 10 now. 8 minus 5, 10. But what we need to do now is we need to change these y coefficients to the result matrix of 2, 3, 1, and write back our z coefficients, minus 12, 8, minus 15. Nice. So now we're going to find the determinant of A2. So the determinant of A2 is just going to be equal to 8 times, this is now 8 times the determinant of 3, 8, 1, minus 15. Then it's going to be minus 2 times cross this, cross this. Minus 5, 8, 10, 15. So this is minus 5, 8, 10, 15. Right? And then finally, minus 12 times the determinant 4. We cross this, we get minus 5, 3, 10, 1. It's going to be minus 5, 3, 10, and 1. So now we work out this determinant, and this will be equal to, so now this will give us a determinant of A2. And as you rightfully guessed it, y is just going to be equal to the determinant of A2 over the determinant of A. Determinant of A2 over the determinant of A. That will be y. Right, so let's work out the determinant of A2. So it's going to be 8 times in bracket minus 45 minus 8, close that bracket, minus 2 times minus 75 minus 80, close that bracket, minus 12 times minus 5 minus 30, close that bracket. This is equal to, put that in your calculator, 8 times minus 45 minus 8 minus 2 times minus 75 minus 80 minus 12 times minus 5 minus 30, and that is, let me make sure I didn't make any error here, minus 45 minus 8 minus 75 minus 80. This is minus 5 minus 30. Yeah, we're fine. So let me put it in again. 8 into minus 45 minus 8 minus 2 times minus 75 minus 80 minus 12 into minus 5 minus 30. All right, so I seem to have made an error somewhere. Let me check again. This is A, 8 minus 5, 10, 2, 3, 1, minus 12, 8, 15. Determinant will be 3, 8, 1 minus 15. This should be minus 45. This is minus 8 times the 8 minus 2 times, cross out this with 2, minus 5, 8, 10. Okay, here's the mistake. You see why I have to be really focused? It should have been a minus 15. And so this would have been a positive 75. We have to be really careful with these things. That should be a positive 75. Yes. Check the last one, minus 5, 3, 10, 1. Okay, now we're good. 8 times minus 45 minus 8 minus 2 times 75 minus 80 minus 12 times minus 5 minus 30. And this works out to be 6. So y works out to be the determinant of A2, which is 6, over the determinant of A, which is minus 1. And so this is working out to be 6. Don't have much space to find z, but let's just do z right here. So we're just going to write down our A3 in blue right here. Oh, by the way, I like to put a box around the solutions. So this is y. All right, so this is now A3 right here. Our matrix A3 is equal to, this is our matrix A3. A3 is, we're going to replace the Z columns now with the result matrix. So we're going to have 8, 3. First Z was, replace this minus 12 with 2 now. Then you're going to have minus 5, minus 2. Then you replace this with 3. Then you're going to have 10, 4. And this is now 1. Nice. So now remember, how do we find Z? We know that Z is going to be equal to the determinant of A3 over the determinant of A. That's how we're going to find Z, the determinant of A3 over the determinant of A. Nice. That's all we need to do. Determinant of A3 over the determinant of A. So let us go ahead and work that out. So now the determinant of A3, let's write it up here, just cause a lack of space. The determinant of A3 is going to be equal to 8 times the determinant of, cross this, minus 2, 3, 4, 1. This is minus 2, 3, minus 2, 3, 4, 1. Then it's going to be minus, let me see, this is now 3 times the determinant of, this is going to be cross that, minus 5, 3, 10, 1, minus 5, 3, 10, and 1, and then that is now plus 2 times the determinant of, cross this, that's minus 5, minus 2, 10, and 4, minus 5, minus 2, 10, and 4. We're going to work out what all of this is going to be equal to. So all of this will, of course, all of this will now be equal to, let's work it out right here. All of this will now be equal to, putting this in the calculator right here, we're going to get 8 times in bracket minus 2 minus 12, close that bracket, minus 3 times in bracket minus 5 minus 30, close that bracket. Then we're going to have plus 2 times in bracket minus 20 plus 20, and we work that out, and that will give us 8 times minus 2 minus 12 minus 3 times minus 5 minus 30, and I get negative 7. We get negative 7. So this works out to be negative 7. And so that means that the determinant of A1 is negative 7 over the determinant of A, which is minus 1. And so that means we get Z is 7. Nice. And so it still works out to be the same thing. Z equal 7. So there we have it. We get the solution for Y, we get the solution for X, we get the solution for Z. Easy, soft. And that is how we use Cramer's rule. Beautiful.